This next example has a polynomial as q of x, the right-hand side. Y double prime minus 3y prime plus 2y equals to x cubed minus 2x squared plus 4x minus 7. Now, you may notice that the left-hand side is the same as in my last example. So, the same characteristic equation, the complementary solution will be identical. Y complementary is c1e to the x plus c2e to the 2x. Well, that's because the roots of the characteristic equation are 1 and 2. 1 and 2. Okay, now what's going to be my trial solution for the particular solution? Well, I have a third degree polynomial. I'm going to use a third degree polynomial. So y particular is going to be ax cubed plus bx squared plus cx plus d. You would use, for a polynomial on the right side, you would use the particular solution, a polynomial with the same degree. Now, even if it was missing a term, suppose this was missing a term, it was just x cubed plus 4x minus 7. Alright, so it's missing the x squared term. You would still use everything I've written here, because we need a placeholder for the second degree. Literally, this is x cubed plus 0x squared plus 4x minus 7. So it's still a second degree polynomial term in there. And so just go with the full descending powers of whatever degree your right hand side is, and you'll be safe in capturing everything you need to. Well, so there's our trial solution, and this time we have 4 undetermined coefficients, a, b, c, and d. And to find them, I first need to look at these derivatives. So the first derivative is going to be 3ax squared plus 2bx plus c. Second derivative is going to be 6ax plus 2b. And now I'm going to feed all these into my original problem. So the second derivative, y particular double prime minus 3y particular prime plus 2y particular will be, alright, so here's the second derivative, 6ax plus 2b minus 3 times the first derivative, so it's minus 3 times this expression. It's going to be minus 9ax squared minus 6bx minus 3c. And then I got a little mistake here. There should be a plus, so please fix that in your notes. Good we caught it here before we start writing more. So plus 2y prime will be, y particular will be plus 2 times this expression plus 2ax cubed plus 2bx squared plus 2cx plus 2d. Now let's collect up those terms and write it out. So I have a 2ax cubed term. I'm going to lightly mark it off as I go along here. For x squared, I've got minus 9a, and then plus 2b, s times x squared. So that cancels off those two. And then the x terms are 6a and minus 6b and plus 2c, all times x. So that takes care of the x terms. And what's left should be constants. I have 2b minus 3c plus 2d as my constant term. So, in order for this to equal to that polynomial, the coefficients must agree. The coefficients of each degree term must be identical. So in other words, I have 1x cubed up here. That means this 2a is equal to 1. This parentheses is a coefficient of x squared, so it must equal to minus 2. This coefficient must equal to 4. And then the constant term must be minus 7. So that sets up a system of 4 equations with 4 unknowns, and I'm going to do some erasing and write up that system of equations, and then we'll go about solving it. I've taken all this down here and organized it into a system of equations, and let's just read it here. 2a equals to 1, minus 9a plus 2b equals to minus 2, 6a minus 6b plus 2c equals to 4, and then 2b minus 3c plus 2d equals to minus 7. So you see that the right hand side are these coefficients, and the left side are the sum of all those constants from the differential equation. So I'm going to erase this, and then we'll solve this. Now, those of you who have seen linear algebra before might recognize this as a triangular system, and I think it's called lower triangular. And you may know from experience that those are kind of easy to solve. And now my calculator will solve this system pretty quick, and it has a simultaneous key on it, SIMULT. So if you have one of those buttons, you might want to explore it for solving systems of equations. It's very handy. You push that button and you can type in the number of equations, in this case 4, and then just type in all these coefficients. Also, if you've had some linear algebra, or if you've learned about matrices, most graphing calculators, if not all graphing calculators, have matrix capabilities. So if you know what you're doing, you can solve it also by doing matrices. Well, I'm going to solve it manually, assuming that not everybody has that capability. And it won't take too long, I don't think, because, see, first of all, 2a equals to 1. So immediately we can solve for a. A is equal to 1/2. And now I'm going to plug that answer into here, in my second equation. So minus 9 times 1/2 is minus 9/2 plus 2b equals to negative 2. And I want my right hand side to be minus 4/2, so I have common denominators. If I add 9/2 to each side, I have 2b equals to 5/2. And then when you divide by 2, this will become 5/4. So b would be 5/4. So now we have a and b settled. We can plug those into our third equation right here. So 6 times a. 6a is going to be, 6 times 1/2 is 3. 6b, 6 times 5/4 is 15. That's actually going to be minus 15. So is that right? No, I don't think that's right. Let me try that again. Minus 6 times 5/4 would be minus 15/2. Alright, so let's make this minus 15/2 instead. And then plus 2c is equal to 4. So let's see, subtract 3, this is a 1. Add 15/2, 2c is equal to 17/2. Divide by 2, c would be equal to 17/4. So c equals to 17/4. And finally, we can use all those numbers and solve for d down here. So I have 2 times b, 2 times 5/4 is 5/2, minus 3 times c, that's minus 51/4, plus 2d equals 2, and thinking ahead here, we're going to need 4 as my common denominator, so this is going to be minus, well, I'll tell you, I'll do that in a minute, it's minus 7. Getting our common denominator is going to be 10/4 minus 51/4 plus 2d equals to minus 28/4. There we go. 10 minus 51 is minus 41. Add 41 to the right side, and we'll get something. 41 minus 28 is 13/4. 2d is equal to 13/4. Divided by 2, d would equal to 13/8. Alright, so I'm going to check myself, make sure I agree with my calculator. my calculator showed 0.5, 1.25, 4.25, and then 1.625, which is 1 and 5/8. That's 1 and 5/8. So that's good news. So we solved for A, B, C, and D. Let's write out the general solution. Now we can present our general solution. Y is going to be, again, it's the general solution is the sum of the complementary and the particular solutions. So y is c1 e to the x plus c2 e to the 2x, and then plus 1/2 x cubed plus 5/4 x squared plus 17/4 x plus 13/8. So there it is. That's the solution to this original problem up here. And as you'll see, there's always two parts. There's the complementary part, which has the constants of integration, for which to solve these we'll need some initial conditions or some kind of measurements to plug in order to solve for C1 and C2. And then this other part is particularly associated with the right-hand side. So there we go. First of all, we've done one with an exponential on the right, an e to a power. We did one with a polynomial. Next, I want to tackle one with a sine or a cosine.